Thank you very much. Hello, everyone. Welcome to KubeCon. Welcome to London. Today, I am going to talk about building a cloud-native curriculum for real-world readiness. I am Marko Mudrinić. For those who know me already, they probably know me as a senior software engineer at Kubermatic, but today I am here to talk about something else. Today, I will talk about the work that I am doing as a teaching associate at School of Computing at University Union in Belgrade, Serbia, and we will see a bit about that. Before we get started, a little bit about my university. So, School of Computing is a private higher education institution focused on information technologies. So we are talking about things like computer science, computer and software engineering, multimedia design, and everything related to that. It's based in Belgrade, Serbia, and it's considered one of the top higher education institutions when it comes to computer science. And also there's our website for anyone who is interested to learn more about. And now a little bit about my work at the university. So I am a teaching associate focusing at teaching cloud-native technologies to final year computer science students. I am in particular responsible for practical sessions and labs. I started in 2023. Before that, I helped a little bit as a student, and we will see about that. And as I said, at the moment, I'm teaching the fourth year students as the studies are taking 4 years in Serbia. A little bit about my students. So we are talking about computer science students here. They are very well versed into algorithms and data structures, programming. They know multiple programming languages like Java. They know how to do the front-end stuff, the mobile applications, AI, a lot of different things. They're also very good with databases, both relational and non-relational. They know how to test the software well, and they also have pretty good maths knowledge. But unfortunately, there's a couple of things that they don't know well. And we are talking about things like Git, Bash or Shell, Linux, Docker, and Kubernetes, and CI/CD. And that's understandable because we are talking about computer science students, and how it works is that most of their projects are 2 to 3 weeks long project, mostly done solo, in some rare cases in 2 to 3 students. So they didn't really get to experience this because the projects beforehand didn't require those technologies. And we figured out that we need to fix that, and pretty much right now, and that's because those technologies are pretty much required to find a job in nowadays job market. However, there were some issues. We initially wanted to get the new course where we would teach all of that, but this is a very expensive and very long process. We are talking about things like changing the university accreditation, all the plans and programs. This requires a lot of approvals. It also requires the government approval, so it is a process that can take multiple years. And the way we found to mitigate it, because we thought that this needs to be fixed as soon as possible, is to change an existing course, which was teaching primarily something else, but to somehow try to fit all of these things, or most of these things that I mentioned. And that this course is the software engineering course. How it looks like? It's consisting of 6 classes per week, 45 minutes based classes, where we have 3 classes for theory stuff and 3 classes for practical sessions per week. The semester is 13 weeks long, and there is about 100 to 120 students per year. The focus area of that course is that we are teaching the software development lifecycle, also known as SDLC, and teamwork, how to work in a team. And other area that we are focusing on is improving the knowledge of Java and software engineering patterns. And all of this is done by creating a desktop application in Java in a team consisting of 3 to 4 students. But there are some problems to that. The first of all, the course, as we mentioned it right now, was not that interesting to students. First of all, everything that we mentioned, they kind of did that on the university already. The course was created maybe 10 or 15 years ago. And another thing is that it is a Java application. First, for students, that's not very interesting, as nowadays it's a lot about front end, about the AI stuff, about different technologies. And Java desktop application is pretty awful combination for teaching Docker and Kubernetes and other cloud native technologies. So we figured out we need something else. Another problem that we had is that this is a required final year course. And we have to keep that in mind because after all, Docker and Kubernetes is nice, but it is perhaps not going to be interesting to every student, and not every student will want to deep dive into that. So we somehow want to make this new course interesting and fun for everyone. And the final problem is that a team of 3 to 4 students is not really a big team after all. And we will see how we solve that on the next slide. So what we did instead is that we came up to have one large project which is done from the day 0, from the first class that they have in semester to the very end of the semester. It is a project that must follow the Scrum methodology, so they must have sprints, actually 10 of them, with 6 checkpoints where the project is evaluated and graded. The microservice architecture is required. They need to have the minimum of 3 microservices on the project, and they also need to have the minimum of 2 different programming languages on the back end. So they learn how to do the cross-service and cross-programming language communication. On top of that, they need to have the front-end application, which is HTML, JavaScript, TypeScript-based, whatever they prefer. And what is maybe the biggest difference for us is that now we have 20 to 25 students per project. This was pretty new for our university, but we decided to take a risk, see how is it going to work, and it turned out to work pretty fine. And that one large team of 20 to 25 students is subdivided into 3 to 4 sub-teams. It is up to students how they're going to do that. Usually there's the backend team, the front-end team, the maybe for mobile, for DevOps, however they prefer. And at the end, the project must be open source, as it is a great opportunity for them to share some of the amazing work they did. So why we did all of that? First of all, working in a team of 20 to 25 people is much more closer to reality than working in a team of 3 to 4 people. We are speaking of students. They're going to get some internship soon, or maybe the first junior engineer job, and they're going to probably work in a company that's not some early stage startup that's like has maybe 50 or 100 people. They're going to work eventually in large teams, and they need specific skills for that, like how to handle meetings, how to have different planning sessions, and we wanted to give them opportunity to experience this before they get to work, and so they have some better start in their career. And with such project, with such idea, you as a student can actually choose what to work on, and you can choose depending on you're interested. So you want to learn, for example, front-end stuff, you can learn the front-end application and work on it. Or if you're AI, you can try to implement some AI for the project. The idea is that you choose something that is close to you and that you work over that semester on improving those skills, while actually getting to learn something about Docker, about Kubernetes, about CI/CD, and some other cloud-native technologies. So the teaching plan idea is that we cover everything on a base level, enough to know how different things work and how to deploy some semi-complex application or stack. And this is pretty much what you need as a junior engineer or as some intern in a company. Probably nobody, unless you pick that as a job, is going to expect you to deploy Kubernetes or to do some advanced administration. But you might need to debug your application or debug what you deployed, get logs, do some stuff like that. And so the teaching plan is pretty much that, in theory, in the first couple of weeks, we start with the project introduction. We then introduce Docker, how it works, what are container, what is the isolation. Then we go a little bit into building images, and shortly after we start with Kubernetes. Also, some weeks on the theory side are for checkpoints that we mentioned, where students are graded, and where we check that their projects are adhering to the requirements, that they're on a good path to successful finish the projects, and stuff like that. On the practical side, so what I mainly do with students is we first start with Git and GitHub, we do the introduction, we make sure they're aware of concepts like forks, branches, how to do rebase, how to fix conflicts as small projects. They didn't really get to experience that, and we wanted to make sure we make it easy for them. Then we focus on GitHub, how to write good issues, how to use project boards, how to do things like properly create pull requests and review them, and so on. Then we have a quick refresher on testing to make sure that they know testing pretty well, but we want to make sure that they know what are end-to-end tests, what are integration tests, and that we are on the same page, as we had some different understanding of each of those concepts. And then we continue with Docker, about Compose, about image registries, how they work exactly. And then we have the CI/CD. We introduce all the concepts, then we have some hands-on sessions, so they create the jobs for their project with us. And at the end, we also go with some Kubernetes, and in the other part of the semester, we continue with each imported Kubernetes concept, and at the end, we add a little bit of Helm, Prometheus, or if there's something else they would like to see, we give them opportunity to propose it and to say, okay, I would maybe like to see OpenTelemetry or something like that. Then we, at the end, put that instead of maybe something else if that's more interesting to them. And this is pretty much how it looks like. And when we come to teaching Kubernetes, the idea that we have is that we provide a solid basis for passing certificate Kubernetes administrator exam. We are not really targeting to prepare them 100% for it, because that would take time, and we want also to teach some other things, but we aim to get at least like 60 to 70%, so if they put a little bit more of work, they can on their own pass the exam. So we focus on things like Kubernetes components, pods, deployments, replica sets, and everything else that you need for a successful deploying application. One thing that students were struggling, especially those that were predominantly working in Java, are that they didn't really get used to some practices to make applications scalable, something that we might call the 12-factor application design. So some of the issues that we had is they a lot depended on stuff like scheduled tasks, the cron jobs, some of those stuff that are not scaling really well with Kubernetes. They also put a lot of hard-coded values and didn't use it configuration files and so on, which made deploying application on something dynamic as Kubernetes pretty hard. So we made sure very early to provide them references to talk a little about, so they know what to expect and how to build the application. And so one key problem remains, and this is how to overcome students not knowing Linux and Shell. And unfortunately, we didn't find a good answer to that. That's because it's only 13 weeks, not too much time, and we have a lot of concepts to cover, but getting rid of the administration of that they actually need to run Kubernetes helped a lot, because they still got very valuable knowledge, the knowledge they actually need on their level, and we focused on different things. Especially when teaching Docker, we use this opportunity to teach them about isolation, about how C groups work, how namespaces work. I pretty much spent more than 1 hour describing all of those concepts, and they did understand it pretty well, and it's important they know what are the shortcomings when it comes to isolation and containers, and then they can build on that depending on if they're interested to learn more. And also what we do is that we embrace the UI. So there are some pretty awesome graphical user interface tools like the Kubernetes dashboard, the headlamp, even K9S, even though it's actually a shell thing, students find it pretty good and use it a lot. At the end, we have a little bit about CI/CD. So CI/CD is something that we can't avoid nowadays, that whatever job you find, you're going to use CI/CD for sure. But there's so many CI/CD platforms out there. We all know about GitHub Actions, about Jenkins, about many different solutions. At this level, we can focus at only one. And so we figured out that whatever platform we decide to pick, it's very likely that students are actually not going to use it tomorrow in their job. And we focus on the concepts instead. We teach what is the CI, what is the CD, what's a pipeline, what to run in CI, what to run in CD, how to build jobs, and of course, what to run in each job. But when it comes to the platform choice, we thought that it would be nice to somehow combine CI/CD, Kubernetes in Docker all together in one package. Why is that? So first of all, some requirements that are important to us is that we are able to centrally manage jobs and merge criteria, because if you leave that to students, they might make some rules that are not that well, not that good. For example, that they can merge stuff with failing tests and so on. Students like to do such things to make the projects easier. So we decided that we want to manage this centrally and to have some possibility to enforce some rules on all of their projects. And then at the end, we would like to run CI/CD jobs as Kubernetes pods, because that way we get to teach Kubernetes on multiple levels. Like some of them will work on deploying application, on making sure everything works, but not every of 20 to 25 students can do of that. But for those that don't do that, they can get exposed to Kubernetes and Docker by actually running the CI/CD jobs, knowing how to write them, knowing how to get logs, and do some debugging and stuff like that. So we try to expose pretty much as many students as possible to those technologies. And there is a pretty awesome CI/CD platform which is called Prow, which actually satisfies all those requirements that I mentioned here. And it's a CI/CD platform built by Kubernetes project for its own projects and sub-projects. It's relatively simple to deploy and use. It's resource lightweight, written in Go, and of course, easy to deploy on Kubernetes. What's important for us is that job definitions are very similar to pods. We will see that later. And it has a very powerful CI that comes with a lot of built-in plugins, and you can also create your own plugins if you need anything additionally. However, the issue and what is important to mention is that it has some pretty considerable downsides. The first one is that it doesn't provide pipelines, so you can't connect different jobs together. And we actually think that this is not too bad, because then you get to learn how to build jobs without any relation and how to test different things. And we believe that it's easier to eventually adopt the pipelines later on if needed, rather than if they end up in a situation that they are used to pipelines and then switch to something that doesn't have it, that might take some more effort. So it comes not too bad at the end. Another thing is that it doesn't have as many users. Some big companies are using it out there for their Kubernetes offerings, but it's very unlikely that students will use that platform. But as I said, there are so many of them. It's anyways, whatever we pick, very good chance that they're not going to use it. So yeah, it is what it is. And at the end, a lot of functionalities are based on GitHub labels. So if you have a lot of students having the write access, they might interface with some of the functionality, but we reduced the write access to maybe just a few students because Prow has a lot of plugins where you can apply the labels and do the project board stuff and everything that you need. This is how the UI looks like. As you can see, it's relatively lightweight. It shows you the jobs. You can filter things. And as a student, this is pretty much what you need. And this is for previewing logs. Similarly, very lightweight, doesn't have a lot of things. You can see what you need, and that's pretty much it. And maybe what is the most important is like how the job looks like. So maybe you can already see something very similar that we got used in Kubernetes, and this is the container spec, and which is pretty much similar to the pod spec that we are already used to. It has some things like providing the job name, providing the run criteria, so when to run this job, or if you want to run it in any case, and this is how it looks like. And for the end, very quickly, we don't have a lot of time, but about the students' feedback on this. Every year, we survey all students at the end of the semester. Last year, we got 98 responses in total out of 100 or maybe 110 students. There are 55 questions about performance, expectations, the effort they need to put for the project. We are working on publishing a paper about this. I am not yet sure when is it going to become available, but you can follow me and I will definitely post this as soon as it's available. And some of the answers were like, I believe that participating in projects related to DevOps and CI/CD will significantly enhance my professional skills and career opportunities. A lot of students said agree and strongly agree. Some of them were not sure or were disagreeing, but many students actually found this very helpful. And participation in this project has significantly contributed to my professional development and decreased my chances for a successful career. Most of them said agree and strongly agree. Some of them didn't agree, which is an indicator that we are on a good path, but that we definitely need to invest some time to try to make it even better, so we make even more students happier about this. And finally, when we asked what would you like to see added to the course, this was a single choice question. A lot of students selected deployment of cloud providers. Also, a lot of them selected nothing. And some of them were other and advanced debugging and monitoring observability. Unfortunately, deployment of cloud providers was out of scope for us because we have more than 100 students. It would be very expensive, and we were not able to secure some backing by cloud providers. So we used our own infrastructure, but we are working on improving that. And this is the projects from the previous years, so where you can see some of the works, wonderful work that my students did. And for the very end, I would like to thank to my university and the professor in this course, Dr. Miloš Radenković, for this amazing opportunity to be able to work on creating this course and to be able to teach on the university. And that will be it for today. Do we have time for any questions?
Yeah, we definitely have a minute if there are any questions. If not, thank you so much, Marko, for your presentation.